mad scientist with his secret lab, humpbacked helper, and unwavering dedication to creating life from scratch.
It's alive! It's alive! It's alive!
I recently visited the mysterious Mountaintop Laboratory of the it's actually the bioengineering department at the University of Maryland, where the not mad at all Dr. John Fisher discussed his lab's work in human tissue engineering.
We're trying to create an engineered tissue or a viable living tissue that we can implant, and that construct would facilitate or help the body regenerate the tissue has been lost, ultimately leaving functional, normal, healthy tissue in its place.
Meaning that someone who suffered trauma or illness could basically grow back missing portions of their own tissue or bones.
So these are synthetic polymer scaffolds. And these materials are stiff, they're strong, so they could be used in bone applications.
For researcher Martha Betts, it's craniofacial bone that she's working on.
Yeah, it's the area right underneath your eye.
It's particularly brittle and often a challenge to repair, making it a perfect choice for this type of procedure.
Since we were working with stem cells, we were able to differentiate them into bone cells. Since we look at how the cells communicate with each other, we were able to show that this material enhanced that communication.
Communication between the scaffolding material and the adult stem cells, which are taken from the same person receiving the treatment, can help direct the cells into becoming bone, skin, or tissue cells. While this lab is working with repairing smaller portions of tissue,
that's not to say that some aren't trying to think about how to create a fully functional lung or a fully functional bladder.
Exactly what researchers down at Texas A&M University are up to, even using that quintessential mad scientist tool, lightning. Well, kinda.
Sort of came across almost by accident this effect, this Lichtenberg effect, and it's been studied a lot in terms of lightning or lightning strike patterns on the ground would make these kind of tree-like structures. And it just struck me that these look like sort of vascular type structures.
Enough so that Ugaz and his colleagues are using that vascular effect as a means of providing circulation to larger engineered tissues.
One of the biggest challenges in tissue engineering is how do you keep a growing tissue well fed and help it survive and sustain it. This network basically serves as a conduit for giving nutrients.
Breathing life into the possibility for more complex bioengineered tissues and even organs. For Discovery News, I'm Jorge Ribas.